the American system, because American academic year starting from the September, but I'm not sure. Anyway, so I have a question. So the academic year started from the September, right?
Yeah.
But the age of so the kids that enter the school is from the January to the December of the
There's a cutoff in December.
also in the December.
Yeah.
Oh, okay. Then the most of the ice hockey player gonna born in January. Okay. Anyway, so that's what happened. 그래서 여러분 혹시 친구 중에 빠른 친구들 있어요? 빠른? 나는 이제 빠른이다. 그러니까 이 중에 빠른 뭔지 알죠? 예. 제가 학교 다닐 때는 빠른이 굉장히 많았어요. 예. 왜냐면은 1년 일찍 온다 그랬는데 요새는 빠른이 이제 굉장히 적죠. 왜냐면 이런 문제 때문에. 네. 그래서 빠른을 하면은 우리가 1, 2, 3이니까 최소한 6분의 1이 빠른이 돼야 되는데, 네. 그렇지 않죠. 네. 빠른이 요새는 많이 없습니다. Okay, so in general, so basically we want to know the probability that y is larger than 50 given x is less than 30. So basically we want to measure this probability, and this probability, because it's a conditional probability, we can use in this way. So it is probability of x is less than 30 and y is larger than 50 divided by probability that x is less than 30. Is it right? So it's a definition of the conditional probability. But this one, probability that x is less than 30 can be, if you think about it a little bit more, it is equal to probability that x is less than 30 and y is less than infinity. That includes every y. So basically, any conditional probability can be calculated from probability that x is less than something and y is less than something. So by calculating the probability that satisfies these two conditions, we can calculate any of the relation between x and y. So that's the actually basic concept of the joint probability distribution. That's the concept of the joint probability distribution. Okay, so here, key point of this the two random variable is joint distribution. Joint distribution. Okay, so for random variable x and y, we define joint cumulative distribution function. So this is the same CDF, but it's a joint CDF. It's defined by, so first we denote with a large F, and because it's between x and y, here on the subscribe we use x and y, and it's a function of small x and small y. This joint CDF is defined by probability that random variable x is less than small x and random variable y is less than small y. This is the definition of the joint cumulative distribution function or joint CDF. In the graphically, this is the two axes. So the axis of y and x and y. So at some point of the small x and small y, this probability means this x and y locates in this area. So the all of the probability that x and y is located in this area, that's the joint CDF function. Okay. So this is a joint CDF because usual CDF is given as probability that x is less than x. Okay, so let's look at the probability of a joint CDF function. Joint CDF function. Okay. Definitely, what's the minimum value of what's the smallest value of this joint CDF? Because it's a probability, it is 0. It cannot be negative, right? And what's the maximum value of this function? 1, because it's a probability. So you may remember that okay, so here is another thing. We say this is a joint CDF, and CDF of the 1, let's say fx of x, so in contrast to this joint CDF, we call this one as marginal. So we say this is two variable. We say the joint CDF, but one variable we often call it marginal. Marginal CDF. You know what's the margin? Okay. So the margin is this side. This is the margin. Okay. So that means this is a plane and this side. This is a margin. So we say this is a marginal CDF. Anyway, this joint CDF has the very same share the similar property with the marginal CDF we already have looked at. So 마이크 하고 할까요? 예. And the second is, let's think about the 2 points here, x1 and y1. And let's think about this point, x2 and y2. Okay? That is, x2 is larger than or equal to x1, and y2 is larger than or equal to y2. Y2 is larger than or equal to y1, so it locates at this point. Then when we compare fxy of x1 and y1 and fx2 and y2, which one would be larger? x2, y2, yes, definitely. Definitely, because it actually has covers wider range. But how about by comparing, let's say, fxy and x1 and y1, and let's say, x2 and y3, but y3 is less than or equal to y1. So in this case, can you compare? Can you make any conclusion? No, because in this case, it locates here. So its range is like this. So we cannot, easily compare this one and this one. We have to calculate. But if x and y are both larger, then definitely this CDF is larger. Okay. That means this the fx, this CDF also monotonically non-decreasing at this side, at this direction. Not only this direction, at this direction, right? So it actually shares the same properties. And how about this? And that one. And the property 3. So if we think x and infinite, so if the y is infinite, this is the probability that x is less than x and y is less than the infinite. So this condition, y is less than infinite, it is satisfied by any y. So this is just probability that
x is less than equal to x, which is CDF of x. So if y is become infinite, then this, the joint CDF becomes one-dimensional CDF. In other words, marginal CDF of x. So similarly, fxy of infinite and y is marginal CDF of y. So it's very, obvious. Okay, and another thing. Okay, so let's think about in this plane, in this coordinate plane, x and y. So as we have seen, if we move this direction, it is monotonically increasing, actually non-decreasing, because there can be a flat part. So if we go to infinitely, that means f infinite and infinite. What's the value of f infinite infinite? It's gonna be 1, right? Because the probability that x is less than infinite and y is less than infinite is always true, so it's 1. How about if we go to infinitely in the other direction? That means f of minus infinity and minus infinity, it's gonna be 0 definitely. Then that's very obvious. Then tricky part is what happens if we go to this direction? That means f of x is infinite and y is minus infinite. What's going to be this value? Undefined. Okay, so what's going to be this one? This is probability that x is less than or equal to infinite and y is less than equal to minus infinite, right? So what's going to be this value? What's going to be this probability? 자, 이 확률은 얼마일까요? x가 무한보다 작고 y가 마이너스 무한보다 작다. 이 확률은 this probability should be 0, right? Because every x satisfies this one, right? But this probability should satisfy this condition, both of this and this condition. But every x satisfies this condition, but none of y satisfies this condition. So the end property is 0. So this point is 0. How about this one? If we go to this one, in this direction, it's also 0. Okay. So you can actually easily think about. So at this point it's 1, and the all other direction is 0. So starting from the 0, and it goes to the 1. Okay, that's how you'd actually look at. 자, 여러분 맞죠? 네. Okay, so then property 5. Property 5 is, it means like this. Okay, so in this way, so here we want to find out x is between x1 and x2. X is between x1 and x2, and y is between y1 and y2. So we want to calculate this probability. Okay, so that one, probability that x is between x1 and x2, y is between y1 and y2 means can be calculated as an area of this rectangle. And how we can calculate from the CDF? So you can easily do that, right? So starting from the probability of this one in here. So this is f x2 and y2. So this one includes this part, this part, this part. Here we subtract this one, this part. So here we subtract fx2, comma y1 minus minus fx1, comma y2. That is this part. We also subtract this area. But in this case, we subtract this area twice, so we add back. So finally, so in certain area, the probability of the in certain area can be calculated in this way. Right? So it's not. Okay, so the basic goal is we want to calculate this area, right? Using the CDF. So in order to calculate this area, we starting from this value. This value is the whole probability of this one, everything. Then from here, we subtract this one. This one is this one. Then we also subtract this one, right? This one. But if you look at that, this part is subtracted twice by this one and this one, right? Then that's why we need to add back this one, this part once. Then that's this point. 뭐 여러분 뭐지? 이런 거 많이 해보셨죠? 네. 그래서 별로 어렵지 않을 겁니다. 네, 이거 하시면 되고요. Okay, so we defined the CDF in this way, and this is some property of the joint CDF. Definitely, from this joint CDF is defined for both discrete and this one is defined both for the discrete and continuous random variable. Both. Okay. But equivalently, the CDF has the equivalent information. Okay, for the discrete random variable, this CDF has the equivalent information with probability mass function. Right? CDF can be converted to the PMF, and PMF can be converted to the CDF for the discrete random variable. Right? Similarly, continuous random variable case, CDF can be converted to the probability density function, and probability density function can be converted to the cumulative distribution function for the one variable case. And this is the same for the two variables. So from the joint CDF, for the discrete random variable case, we can define joint PMF. And from joint CDF, for continuous variable case, that means x and y are both continuous. You have the joint PDF. Okay, again, if x and y are both discrete random variable, we can calculate joint PMF, probability mass function, from the CDF. If x and y are both continuous random variable, then we can calculate joint PDF function, joint PDF functions. What happens if one is continuous and the other is discrete? In that case, we can also define something, but it's not that simple. So you need the more sophisticated mathematical tools like direct delta function. Direct delta. Have you heard about the direct delta function? Delta function. Maybe in the engineering mathematics, you're gonna handle the delta function. So if you use the delta function, you can handle this one is continuous and this one is a discrete case. However, we do not consider such a case, at least in this course, because it's quite complicated. Okay, so let's look at. So here we want to know, define joint probability mass function, joint PMF, and joint probability density function, joint PDF. Okay, so discrete random variable case, joint PMF is defined by probability that x is equal to x and y is equal to y. So this one is in the same definition for the one random variable. Okay. How about this one? How about the continuous random variable PDF case? So joint PDF is very similar. So this one is actually so the definition is like this. So because it's a density, at certain point of the x and y, it actually first calculate very small, the probability in the very small area. In the very small area. That area is x. So this area has a dx and dy. Dx and dy. So the probability on this small area is calculated by probability that x is between small x and x plus dx, and y is between y and y plus dy. This is a very small probability, and because we are considering already density, so we use the relative probability by the area dx and dy. So if we actually send this dx and dy to the very small value, that is actually differentiation of this CDF function. And finally, it is like this. Oh, okay, typo. This is x and y. So if we send it, then it actually becomes to the square of the x and y over round x and the round y. So the joint PDF is finally defined by in this way. So it's the same for the one random variable. PDF is the differentiation of the CDF using that one variable. In the joint PDF case, the joint probability density function is derivative of the joint CDF using both two variables. Okay, so everything is the same actually. Alright, so 자, 여러분, 그러니까 조인트 PDF가 어떻게 디파인되는지 아시겠죠? 네, 그러니까 변수 하나일 때랑 똑같아요. 변수 하나일 때 똑같고 해서 두 개일 때 디파인하고, 네, 두 개 배운 다음에 우리 이제 세 개로 갈 거예요. 이거 끝난 다음에 세 개 배우고, 그 다음에 네 개는 안 배우죠. 네, 1, 2, 3. 보통 이렇게 되죠. 1, 2, many. Okay, so we are handling two random variables. So because we already learned one random variable, then we're gonna learn about we are learning about the two random variable. And next is not 3. Next is many. 1, 2, and many random variable. That's called the random vector. Then what's the next? What's the next of the many? Next is infinitely many. Infinitely many. There's infinite random variables. That's the random process. So that's our step. So then the most important thing is the two random variables. So you need to understand very well about these two random variables. Okay. Okay, this is the basic concept of the joint PDF, joint PMF and joint PDF. And let's see how we can calculate the marginal PMF or marginal CDF. Again, marginal means one random variable. Okay? So in this case, in order to calculate the marginal PMF of X, we just add sum up using for the all Y's. Then we have X. Is it right? 요즘아 7페이지로 가볼래? Okay, so let's look at this example. Simply this example. 이 부분만 좀 확대 안 되나 이거? 어렵나? Okay, so let's look at this example. So this example is a typical. It shows the typical case of the joint PMF. And in this case, probability. So joint PMF of the X and Y of 0, 0 is a probability that X equals 0 and Y equals 0. And that probability, according to that table, it is 0.01. 1. So we can interpret that table in this way. So in here, if we want to calculate the marginal probability that X equal to 0, this is the marginal probability of X to 0, right? This probability, the probability of X equals 0 should be this one plus this one plus this one. That means it is the summation over all of Y's for that specific X. Okay, so then what's the probability that Y equals 0? That means add this number, and this number. That is the summation over all X for specific Y. Okay? 유정아 다시 앞으로 가보자. Okay, so this is the very obvious and very intuitive. And if you express this idea with mathematics, it looks like that. So Px of X, so probability for the certain value of X, this one is summation of this joint PMF over all of Y's. So this summation is over Y. So Y that is in the all of the sample space of the Y. Then for this specific X. Then that's the PMF, marginal PMF. Similarly, marginal PMF of the Y is calculated summation over X. Okay? And how about in continuous? In the continuous, it's the same. But instead of summation, we use integral. So fx is integration over y. That means we integrating over all value of the y. So in terms of the graphical notation, so let's say this is x and this is y. So the fxy is fxy is the locate over the whole of the display. And if we want to calculate PDF of a certain value of x, that is integration over the whole very the narrow strip that across the whole y. Right? So that is expressed in this way. Integration from minus infinity to the positive infinity. So in order to calculate the density of this point, we just add up all the density along this the narrow strip. That's the integration. Got it? So it's the same. if we calculate the marginal CDF of y, it's an integration over x. Alright. Then also, if we summate over whole range of x and whole range of y, that means we add up the probability of all possibility. Then it should be 1. And it should be 1. Similarly, if we calculate, if we summate density over the whole range, it also should be 1. So it is the same property of the single random variable, right? So in the single random variable, so minus infinity to infinity for any of the x of x, dx should be 1. Okay, not that difficult. Then the conversion between the PDF and the CDF, PDF or PMF to the CDF. If we want to calculate PMF, CDF in the discrete case, we just summate all the probability that satisfy u is less than x and v is less than y. Then we have CDF, right? So in the x and y case, because in the discrete random variable case, x and y has x are discrete and y are discrete. Y is discrete. That means the point is the sample space is given in this way. Okay. Then the CDF means then each of this one is given as PMF, joint PMF. So to calculate the joint CDF from the PMF, then we just accumulate everything in this area. This one. So in terms of mathematics, it is written as fx of y of xy is summation that u that is less than equal to x and the summation over v that is less than equal to y of p x of y and u of v, u and v, like this. So this is summation over this range, and u and v is satisfied this condition. So they are all over this one, and because it's y, so all over this one. Okay? 자, 여러분, 네, 이해하세요? 네, 잘 아시겠나요? 네. So it's the same. So this is the same. So if it's an integration, if it's a continuous, that should be integration over the whole of this range. So that is integrating from minus infinity to the x and integration from minus y infinity to the y. Then you integrate all of the density, then it will become the CDF. Then the inverse of this relation is this differentiations. So PDF is calculated from the CDF by differentiating using two variables. All right. Okay. Then next is let's think about in this coordinate system. If we want to calculate probability in certain area of A, That is, just integrate the PDF over this range. So the probability that of A means X and Y fall into this, the area of A can be calculated by integration over this A of the PDF. In general, we can express it in this way. But numerically, so that if A is given and XY is given, you can calculate theoretically, even though it may be so difficult. It's the same. So this one is also the same. So in the discrete case, if we want to calculate the probability of a certain area, let's say this area, so this is the area of A, then we just summate all of the X and Y that is included in this A. So discrete random variable and continuous random variable, they are fundamentally the same, so the equivalent, except discrete random variable use summation, but continuous random variable use the continuous version of the summation, that is integrations. Okay. 자, 여러분, 그러니까 네, 사실 별거 없죠. 네. 중요한 점은 이제 변수가 두 개가 돼가지고 이제 조인트가 되는데, 여기에서도 이제 똑같이 CDF와 PDF, PMF를 다 정의할 수 있다. 단지 이제 두 개로 되었는데, 기본적인 거는 우리가 그 변수 하나 할 때 배웠던 CDF와 PDF와 PMF의 성질을 모두 다 따르고 그 관계도 다 따른다. 그리고 우리가 변수 하나 할 때 봤을 때와 똑같이 컨티뉴어스 한 것과 디스크리트 한 것은 서로 동일한데, 네, 서로 동일한데 단지 다른 거는 단지 이게 서메이션이냐 인테그레이션이냐 그 차이다 라는 거죠. 네. Okay, so okay, this is the example. This is the example. Okay, so let's first do the let's do it by yourself. I'll give the what's the time? I'll give 10 minutes. 10 minutes. So please try by yourself. So first, try to find out C, and also try to find out the probability of event A. Okay. Okay, so let's solve it together. Because we are out of time. Okay, so in this problem, X and Y are limited between 0 and 1 and 0 and 2. And the PDF is all 0 outside of this rectangle, and they only have non-zero within this rectangle. Okay, and the PDF, joint PDF is given as C, X, and Y. Then first we need to do is find the value of C. So here, if we integrate all this of the PDF over the whole range, that should be 1. So by using this one, we can do this. That means integration from X equal from 0 to 1, and integration of Y equal 0 to 2, Cxy of dy and dx should be 1. Then I think you can do this. This integration is a quite easy one, right? So you can do it easily. Then finally, this integration become, if you do this integration, it becomes C. Just C finally. Then you can conclude that it's 1. C is 1. Second one is a little bit tricky. So calculate the probability of A. And this A is probability that x squared plus y squared is less than or equal to 1. So this is the probability of the A. That means in this situation, we want to know what is the x and y, the probability that x and y fall into the circle, because this one is given as a circle. So it is a circle like this, with the radius is 1. However, the outside of a rectangle is 0, so we only consider this is the overlapped part, a quarter circle. This part, a quarter circle. So basically, what we want to do is we want to integrate this CDF, joint CDF, x and y, dx and dy over this area A. That area is over this area. How can we integrate? RDRDC. So the one of the so one of the technique is common technique is changing this coordinate to the polar coordinate system. That's the one common technique. That is usually from the 정석. 자, 여러분 정석이나 뭐 다른 수학 과목에서 인테리어 과목에서 그 코디네이트 시스템 변화해가지고 하는 거 아시죠? Okay, so one of the common way is to change the polar system. That is here. In order to do that, we change polar system to the. So instead of the x and y, instead of this point, let's use the other color. Okay, this point, x and y, instead of using x and y, we use r and theta. This is the change to a polar system, right? So in here, x, this one, this is x, become r cosine theta. So x is r cosine theta, and similarly y is r sine theta. Okay? Then what happened to dx and dy? dx and dy, what's the dx and dy in the polar system? R dr d theta. R dr d theta. Because this xy, okay, let's see this one. Dx and dy means the very small area, right? And in the polar system, very small area is calculated by d theta, and this is r. So it's like this. So this is the very small area. So this is the dr, and this length is r d theta. Okay, so this small area becomes r dr times r d theta. So if we put here, and this one is, okay, first r is from 0 to 1, because it should be from here to here, 0 to 1, and theta is integrated from 0 to pi over 2. And xy, xy is, we use this one, so this is r square sine theta cosine theta, and dx dy is like this, so the r dr d theta. Still, it's difficult for me, but I think you guys can do that. If you solve it out, then it becomes, according to my calculation, so r is from 0 to 1, r third to dr. No. So finally, it become 1 over 4 r fourths from 0 to 1 times sine square over 0 to pi over 2. So if you integrate this r part, it become 1 over 4 times r fourths. And if you integrate of this sine square and the cosine square, cosine theta and cosine theta, it become sine square theta over 2. Then we just put the calculation from 0 to 2 pi. And if we calculate everything, the answer is 1 over 8. 오케이? Got it? 자, 여러분 여기까지 하고 자, 질문 있으신가요? 네, 질문 없으시면 네, 수고 많으셨습니다. 네, 시험 보시고 다음 주 화요일은 수업 없고요. 목요일 날 시험, 화요일은 수업 없고 그 다음 목요일에 뵙겠습니다. 네, 수고하셨습니다.